So this week I primarily focused on working on the app. So the program that we're going to be using to create our apps is called Xamarin. And here on the screen we have some example code that we just like to test out how we could install an app to our phone. So right now all it's doing is pretty much has two buttons, one where you could like increment a value, and the other one just as soon as you click it, it displays a message. So if we go over to my phone here, and then we go to our apps, and then right here you can see it's the app we created. The app we created here is called the Smart Outlet, and then we click it, and then when it comes up, it has like two little buttons. So one is Hello World, and it's pretty much just like as you click it, it just like increments number of clicks. When you press power consumed, it'll say constant power consumed displayed. The reason I just have this message right now is because I'm still working with the program, and I'm still learning how to use the Xamarin Studio to keep creating my app. I still need to include the libraries to use my Bluetooth module, and I'm still doing research on that. And then other than working on the app, we have also were able to create multiple files in our current Arduino software. So when we want to like save current or voltage data, we won't have them all in one file. We'll be able to have them in two different files, or as many files as we need to like store either time, current, voltage, power consumed, or like keep track of like the user's input. So and this is going to be very useful when it comes to our overall project when we want to send data to the Android phone. And then that's about it what we've worked on for this week.
Another feature that we've added this week is infrared heat sensor. What this will do is that it'll sense motion of anybody walking into or out of a room. We'll be able to code this up. And the way it works is just your simple V in and ground to power the sensor. And when it detects any movement, the infrared heat levels, it'll send a value back to our microcontroller. So as my partner will now demonstrate, when he walks in front of the sensor, it'll detect him and the light bulbs will turn off. And once he's out of the sensing range, they will turn off after a short period of time. The next section that we worked on was integrating our Bluetooth module, which is the HC05, with our relay. So what we have is that we're using our terminal on our phone. It takes in a 0 to turn off a light, and if you were to put in a 1 and send the signal, it would turn the light on. 0 for off. We've tested it so far from a distance of behind the wall, and it still works all right. I'll give a quick example of walking on over. From this distance, if we were to press 1, it turns on, and 0 off. The last thing that we're currently working on is our current sensor. What we've been doing before is that we've been plugging in different light bulbs and measuring the current of each one. However, we wanted to measure with very small amounts of current, which these weren't drawing. These were drawing about 200 milliamps per each light bulb. So what we did is that we bought an LED with a slider so we can vary the amount of current going in. Right now at this small amount we're drawing in 65 milliamps. And if we would get the slider and vary it, the brightness up and down, we could change the brightness as well as the amount of current that it's drawing in. Based off this, I'm going to write down many amounts of these values, and we'll be able to create a graph. That way we could use these values to tell how much current our outlet will be drawing in.